Jordan is going to talk to us about like you can see the slide right now, under 1 minute compile times with Swift Package Manager. And after the quick break, we'll have Mike join us to talk about like how to write code to avert catastrophe, which is a very interesting topic as well. Without further ado, I'm going to give it to Jordan to get us started.
Thank you, Paul. Thanks, everyone. Thanks for having me. So my name is Jordan Guggenheim. I am the iOS engineering manager here at OkCupid. We're a dating app based in New York. I'm reporting to you live from our office on Gansevoort Street. And today I'm talking about warp speed. Unfortunately, not interstellar travel. I know that would have been very exciting, but still equally exciting. I'm here to talk to you about how you can accomplish under 1 minute compile times using Swift Package Manager modules. And let's jump right in. So does this look familiar? I hope this makes people smile because I think everyone can relate to sitting around and waiting for your code to compile. And, you know, obviously it's a waste of time, but, you know, as developers, we love to build things. And so it's really just a drag and just no fun to wait for your app to compile. So how do we make it better? Well, so this presentation then is for everyone. It's for everyone who wants to learn how to get immediate compile time benefits. Even if you have a very large code base, we're going to show you how to get started and very quickly be able to reduce those build times so that you can start iterating very quickly on new features. But there are some additional benefits to Swift Package Manager. So one is if you're working on a large development team, you can really decrease conflicts by siloing different parts of your code in different modules. And another advantage is you can improve your app's reliability by reducing side effects. So we'll look at a way to organize your Swift Package Manager modules to have very, very clean inputs and outputs so that there are no side effects. And before we get going, the sample project is available on GitHub at my GitHub, so /Googs, and it's pinned to the top, so you'll be able to find it very easily. For anyone who's new here, like no worries about downloading this now or taking screenshots. This slide deck and the code will be made public afterwards, and we'll make sure to share it with everyone. And also I want to mention that our blog, tech.okcupid.com, also has a lot of in-depth articles on how to get going with Swift Package Manager and also a lot of other features across all domains. And I have to give a big thank you to the entire OkCupid iOS team. Everyone here has participated in building out the architecture that I'm going to show you today, and it wouldn't be possible without all their help. So thank you, everyone. And without further ado, let me get started with getting into the meat of it. So the sample project, this is the overview of its folder structure. And here's how I want you to think about it. The main app is your legacy code base. It's all your old features, it's all your dependencies. And in fact, to simulate having a lot of sample code, I've just put a ton of CocoaPods in there. So even though your app may not have as many CocoaPods, the whole point is that I wanted to sandbag the compile times and make it really slow. And next, what I want to point out is the modules folder. So the modules is going to be, this folder is going to be where all the new code lives. So all your SPM modules will be in this folder. And the idea here is that this code can be shared between the main app and the test app. And I'll get into detail about what the test app is. But what I want you to think about conceptually is the main app is what you'll always be shipping to the store because it's your comprehensive code base. But the test app is where you're going to be doing your new feature development. So let's start off by saying that you're going to create this test app, which is going to serve as the lifeboat. And what I mean by that is, well, what do you get instantly by just creating this new test app within your project? Well, you're going to have no dependencies, and you're going to have no legacy code, which I'm sure you're all happy about. And that leads to super fast compile times. And yes, of course, like if you have no code, it's going to be compiling really fast. But I do want to mention that at OkCupid, where we've used this and used our architecture correctly for a long time, even with a lot of code, in this loosely coupled manner, it really still only takes 30 seconds for a clean compile, and incremental builds can be as low as a second. And it's very, very gratifying when you see that you're able to develop really quickly in this new test app. So here is an illustration of that test app. So it's a project in a workspace within a folder just to keep it separate from the main code base. And so here's an example just for this sample project. The main app takes about 236 seconds to compile, and the test app from clean only takes about 4.7 seconds, and that's with all the code in the complete sample project. So you can see you have an ability for an enormous gain when you do it this way. So let's talk about the infrastructure that you need to create. So I talked about you're going to have this module folder, which serves as the home for the new code. And here's a screenshot of it, and you can see it's a combination of infrastructure and even the features that are eventually going to be in the modules. And so let's take a look in more detail. So perhaps the most important module that you're going to have to create to do it this way is interfaces. Interfaces is the contract. It's all the protocols that allow all these features to get injected with their dependencies and to communicate between one another. So, these are just some examples of what you may include in your own interfaces. Something like a log manager for logging to the console, a network interface for, of course, all your network calls, a route interface, which we'll get into in a lot of depth because routing is super important for the loose coupling and transferring of information between one module to another without them having to know about one another. We have this concept called Bootstrap, which a lot of companies have, but if you're not familiar, it's the idea that in Bootstrap, it fetches everything you need to know about the active session. Maybe you're logged out and there's information you need to know about a logged out session. Or if you're logged in, it's going to fetch everything about the user, active experiments, feature flags, whatever it may be. And this experiment interface is part of that. And we're going to see in this presentation how you can turn on and off features in a way that's really loosely coupled with the modules. So first, let's take a look in more depth at the route. So this lives in interfaces. It's public because all the modules need to know what all the routes are that they could possibly route to. And we use this to communicate. And in particular, we use the enumerations associated values. And this one has a closure that when login completes, on login success, it will return an access token. Other examples that you might think of is like maybe you have a home screen and you want to push a profile. Well, you can create some standardized models that also live in interfaces that you can then pass data like a user's profile from one module to another. The other really important part of routing is what we call the route request responder. And think of it like a builder. The route request responder is a way of returning the view controller for a feature or not. It's optional, and we'll get into depth and we'll see in the demo how that works. Last thing that I want to point out is the application states. I think these are pretty cool. And what they do, so this is the logged out application state. What they do in the context of routing is you can see it defines the routes it supports. So for the logged out state, the only route it supports is the login route request responder. This is really important at OkCupid because, for example, let's say a user gets an email to go to a profile. Well, what if the user is logged out in their app? So they click the link and the app opens and we accidentally send them to profile, but they're logged out. The profile will fail the request because there's no authentication token and it's just a bad experience. But in this architecture, because you're able to specify what routes are supported by what states, the logged out application state only supports the login route and all other routes are ignored, which is a much better user experience. Next, you'll see in each application state, there is the business logic for what is the home screen of that state. So in this example, the logged out application state, its home screen is login, which you can see here. And that associated value, the closure that we were looking at on the other screen, when login completes, it's going to return an access token, which we're going to set on Bootstrap. And if everything goes right, when Bootstrap is fetched, it'll then change states and you'll be logged in. And then here, the final part of this state is we request from the router, the view controller for the login route. It needs to return, and then we set it. And then just quickly for illustration, logged in application state has a bunch of routes that it supports. And this is going back to that point of being able to separate what routes are supported by what state. And then one last piece is the core manager. The core manager is the glue. And what I mean by that is, so here's your application delegate, and the core manager is retained here because it needs to be around for the whole life cycle of the application. So you'll create your window as you normally do, but then you create the core manager. And what you do here is first you create all of your dependencies. So here are all the concrete implementations of the protocols. And then you also specify the types of all the different states: loading, logged in, and logged out. So now let's do a quick demo. So here is the app delegate of the main application. So you see the core manager, like I was pointing out. And one thing I want to show you in particular is how you make like your CocoaPods work within this framework. So let's take a look at the concrete log interface. So if I click on this, you'll see we wrap in this concrete log interface a call into Firebase Analytics. And so that's great because we can, log to both the console, but also to a dashboard that we can see things in. But now, so like that is injected here into the interfaces, and then that is used in all of our features. But now if I quickly switch to the test app, which I have aliased in Bash, now when we open this, you'll see in the test app, so it looks very similar, but don't be confused. We're now in a different project. And instead, where there's no dependencies, you have this mock log interface. And here, now there's no more Firebase. And this is fine because when you're developing just a feature, you don't really need to know about Firebase or have that kind of functionality. But you're able to still be able to build and compile and do everything you need to do otherwise. So I'm going to switch back to the main app. And the next thing I want to show off is this idea of routing. So first, let me show you the concrete route interface. So here are the methods where you add the routes. And the first thing I want to point out is the route request responders, these builders, are an array. And when a route is requested, we just iterate over the array, and the first one to return non-nil, well, that one wins, and that view controller is what's returned. So you might be thinking to yourself, like, well, wait a second. What if two route request responders support the same route? Like, one's going to get returned first. It'll be a silent failure. Like, what's up with that? Well, this is actually by design, and we've done this for a couple reasons. So in the main app, we have a physics experience. So first, let me illustrate what I'm talking about. So I'm going to sign in, and then here is the physics experience, which is super fun. And I don't think the Zoom frame rates are going to do it justice. So definitely download the sample project and check it out. But let's say one day we want to replace the physics view controller with a new experience. So this is the physics route request responder. When the route is physics, it returns. But then what about the new physics experience? So here you see the new physics route request responder. And you see here instead that it first checks that the experiment is active. If it's not active, it returns nil. And otherwise it returns the new physics view controller. And what's super nice about this is, instead of having to have a lot of if-else statements and cases like throughout your app to like, oh, if the feature is on, do this, if not, do that. It's all encapsulated within these route request responders. And then when one of the features wins, all we have to do is delete the feature and not have to tease apart a bunch of different code. So if you see in the logged in application state, right here, the new physics route request responder has to be listed before the old one because this order determines the order that things are added to the array. But it works very well for us. And I'll just show you really quickly. you can, in the sample project, toggle the experience. And then when we come back here, we now have the new physics experience shown. So that's really cool. And I think, one last thing I'll show you is, let me go back and let me launch the test app. So what you'll see here is the test app has the same login view because that code is shared in a module between both code bases. But when we sign in, it just goes to this discover view, but notice there's no tab bar, there's no settings, there's no physics, because that code lives within the main application. So the test app doesn't have that. But that's really okay for us at OkCupid. And what I mean by that is, when you're coding, you really only need to focus on the one feature that you're working on, and usually you'll set it as the root view of the test app, and that saves a couple clicks even, and that allows you to iterate very quickly and take advantage of the quick compile times. And then when you're done coding the feature, maybe you'll switch back to the main app, wait for the longer compile time, and see that everything integrates the way you expected. But a lot of the actual building out of a feature can happen within the test app. So with that, I want to switch back to the presentation. And so I want to just talk about a few tips that we've learned over the months and years about what's the best way to do this. Well, first, do not import feature modules into one another. Use the router. And that's extremely important, like for a number of reasons. One, you want to prevent circular dependencies. An example being like feature A imports feature B imports feature A, and you just want to avoid something like that. And in fact, I want you to think of it as a unidirectional data flow. So if interfaces is injected everywhere, so think of it as like the top of the chain, then it gets injected everywhere, and then all those modules get imported into the main app, and that keeps everything very clean and not circular. Another tip is only make public the bare minimum in modules. So this goes back to my point about how the test app at OkCupid has remained very quick, despite the fact that we've now added a number of features into modules. And so to take a look at one example, the discovery feature in the sample app, the only thing that's public, the only thing is this route request responder. And the whole rest of the code base for this feature is internal and essentially private to this module. If you do it this way, you're going to be able to prevent a lot of issues with compiling. Like if you change a part of the code and it has to rebuild a bunch of things, that's no good. So make sure that you always just keep the route request responder public and the rest of everything in the module internal. Another tip, and this is kind of a quirk of this architecture, is you can't have both the main app and the test app open at the same time. So if you do that, and usually you don't need to, but if you do accidentally open both, you'll see this error that says you cannot load the module because it is already open in another project or workspace, and simply just closing both and then opening the one that you want to use resolves the issue. And another tip that goes along with some of these benefits of modules is that you can add resources directly into them. And we really like this. So you'll see in the sample project a resources path. And so we actually add an entire directory in the package. And you can import colors or images. One small quirk is that you have to reference them by bundle module. But what's really nice about this is, let's say you have a bunch of images for a feature, and one day that feature goes away. Well, if it was all in the main application, you may delete the feature, but forget that you have images hanging around in the asset catalog. And that adds to your bundle size, and a bigger bundle size may deter people from downloading. So when it's all in a module and that module goes away, that feature gets deprecated, you can just right-click delete and be sure that all the images and everything else gets deleted. And one last thing I want to mention, there's no slide for it, but when you're building out the test app in your own project, one good tip is to start with the login feature. Once you get all the infrastructure in place, most of the features at OkCupid you can't do if you're logged out. So building even a lightweight feature for login where you can authenticate will allow you then to iterate and do some other cool feature work. So with that, that's it. And thank you again. I want to open up for questions if we have any time.
We do have time, but everybody is muted. I don't know how you want to do it, Scott. Maybe
we can just read from the chat for now, and then obviously with the breakout rooms later, they'll be able to ask questions additionally directly then too.
Cool.
So yeah, I didn't announce at the beginning. Sorry about that. I usually have slides. I forgot today. We will have a networking session after the second talk. We'll have breakout rooms. Everybody will be able to go ask more specific questions. But if you have a question right now, you're very welcome to ask in the chat. And if you don't mind reading it, Jordan, before you answer, that would be great.
So the first question, I don't have experience with build systems like Buck, but is this similar to how Buck Bazel works? So I know I'm familiar with Bazel, and what I'm familiar with, although we don't use it at OkCupid, is that Bazel is very smart about knowing what parts of your code to rebuild or not. And it's not similar in the sense that there's no third party here. Everything is made by Apple. And what we're really doing is just structuring the app in a way that can compile really quickly and take advantage of Apple's tools. And please someone correct me if this is mistaken, but I think with Bazel, you have to, it generates like a binary, and then you have to drag that binary onto your phone. So the advantage of doing it this way with the Swift Package Manager is that you can save a couple steps and it builds it directly on your phone because you're just using Xcode.
There are ways to get Bazel and Xcode integrated so you can directly deploy the device, but yeah, it's a little more extra hoops and steps than just having something directly on Xcode build. So there are some trade-offs there.
Cool, good to know. So the second question, do you generate those mock interface implementations? Do you keep them in a single module or various ones? So the mock interfaces all live in the test app, and we just put them in the main test app, but you could conceivably put them in a module of their own. It would work the same way. You could have a concrete implementation of a mock that you only import into the test app, because the modules don't actually get imported automatically. When you create a new module, you in the Xcode project, you click import and you have to be declarative in that way. So you could very well conceivably just put them in a module. If for the sake of the sample project, I just created those mock types in the test app itself, because there aren't that many for us. Next question. Do you recommend modularizing code like this for projects with legacy code and Objective-C mixed with Swift? So, up until very recently, we did have Objective-C code in our main app. And I think that also kind of hurt our compile times is sometimes the bridging. In terms of what we have modularized, we've only modularized Swift code. So it definitely does work in a hybrid app, but I can't speak to putting code like Objective-C code in a module or anything like that. Next question. A lot of times we need to share resources throughout the app. Do you have duplicate resources for each SPM that requires, so this is a good question, and it's something that we came across. So a good example of a shared resource would be, maybe your logo, maybe a bunch of different pages in your app have your logo. Well, what I want to encourage you to think of is you can create a router for images. So you can store an image that is going to be used in a bunch of different modules. You put that in the main asset catalog in the main app. But then maybe you create an enumeration for, give me the asset for .logo. And because it's injected from the main app, that's a way that you can share images in all the different modules that, without having to have redundant images in every single one. And that's the last question for now. So anyway, thank you again.
One more. Now,
one more.
The question under that will be.
Oh, sorry.
Yeah.
Can you do the same thing in terms of fast compile times with build configurations like debug build or release build? within the same project. You know, there is something that we do. We have one very, very large dependency that even in the main app, we didn't want it compiling every time. And one thing you can do is use like a can import statement. And you can use macros and things like that in your main code base to prevent certain things from compiling when you're in debug mode, or if like the feature is not what you're currently testing. So there are ways that you can do that. But ultimately having the test app, I think, is the best because you have no dependencies and you're able to just focus on the feature work. And with time, more and more of these features will be in modules and it'll be more worthwhile. But yeah, you definitely can do some things within the main app to even improve it there.